Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 434, which is maximum frequency after Subarray operation. So what is the problem? We are given an array nums of length n and also an integer k, and we have to perform the following operation exactly once. So we have to select any subarray from the array and add x, select an integer x and add x to all the elements, and we have to find the maximum frequency of the value k after this operation. Okay, so let's take one example where nums is 1 2 3 4 5 6 and k equals to 1. Okay, so let's take this array. So our nums is equals to 1 2 3 4 5 6 and k equals to 1. So what we have to do, we have to take any subarray of the given array. We can take this subarray or the entire array itself, and we can add any integer x to every element of the subarray. Okay, and we have to find the frequency, maximum frequency of 1 in the in the array after this operation. So let's take this subarray. Okay, let's take this subarray 3 4 5, and here if we add minus 2 to all the elements of the subarray, the array will become 1 2. We are adding minus 2 to this element, so it will become 1, this will become 2, and this will become 3, and this will become 6. So the total number of frequency of 1 in the array is 2. Okay, so this is the final answer. The answer will be 2. The maximum frequency we can achieve is 2. The maximum frequency of 1 we can achieve is 2 by performing choosing any subarray and performing any operation. Okay, so this is the answer for the first element. Okay, now sample. Okay, now how we are going to solve this problem? So what is the brute force solution? The brute force solution is obviously to consider each and every subarray. We can consider each and every subarray and try to add any element to that subarray, to the elements of that subarray, but that will be like, we are adding every element. Here you can see that the value of numSci is 50, so you can think that we'll iterate over all the subarray in n square, and we'll try to add from 0 to 50. So we are adding 0 to 50, so n square into 50 could be our time complexity, but here n is 10 to the power 5, so this solution will not work. So how we are going to solve this problem is the question now. The one important thing is that the first observation, the most important observation here is that we are choosing a subarray. When we are choosing a subarray, the maximum frequency of any element in that subarray matters. So let me give you one example. Okay, so let's say our subarray is like this: 1 2 2 2 and 1. Okay, now we are choosing this subarray. Okay, now the maximum frequency in this subarray is of 2. Okay, so we can change each 2 to 1 by adding minus 1 to each element. Okay, so let me take another example. Let's say the subarray is like this: 1 2 3 2 3 2 1. Okay, so here if we choose this subarray, we can either convert all the 3's to 1's, or we can either convert all the 2's to 1's. So here the maximum frequency of element is 2. Okay, maximum frequency element is 2, so we'll change this 2 to 1 by adding minus 1 to each and every element. Okay, I hope you get it. So that is the first and most important observation, is that we have to choose the maximum frequency element in this each subarray. Okay, in each subarray, and then we can do this. So our time complexity is now reduced from order of n square into 50 to order of n squared. So what we will do, we will try to find the maximum frequency element in each subarray, and that will be our desired answer. Okay, now here comes another interesting case where a subarray contains the k value. Okay, so let's say our array is like that: 1 2 1 2 2 2 1 and 2. Okay, now let's say we are taking this entire thing: 2 1 2 2 2. Okay, now here you can see that if we add minus 1 to each and every element, the this one is getting changed. Okay, this one is getting changed, so we are getting minus 1 once. Okay, so when we are changing 2 to 1, we are getting plus 1, and when we are changing 1 to 0, we are losing 1 1. So we can say this is plus 1 here, and this is minus 1 here. Again, this is plus 1 here, plus 1 here, plus 1 here. Also, let's say we are taking this one also, so let's say this will be minus 1 here and plus 1 here. Okay, So if we take the max Subarray sum from this plus 1 and minus 1, we will get our desired answer. I hope you get it. So what we are going to do is that for each and every element here, AI is from 1 to 50. So we can build this plus 1 minus 1 array for each and every value of AI. Okay. So let me take one example. Okay, let's say our array is like that: 1 2 2 3 1 1 3 2 2. Okay, let's say this is the array. So we'll try to build this plus 1 minus 1 for each and every element, which is not equals to 1. Okay, k equals to 1 here. So we'll try to build this plus 1 minus 1 array for each and every value like 2 and 3. So let's say that we are trying to build for 2. So 2 is not equals to 1, so we are losing if we try to change this array 1 by minus 1. So we will be losing 1 1. So this will be minus 1. Now if we add 2 minus 1 here, we will get 1 1. So this will be plus 1. Again, if we add minus 1 to this element, we will be getting 1k. So this will be plus 1. Now if we add minus 1 to this, we will not be getting 1 also, or we will not be losing k also. Okay, we will not be getting k or not be losing k also. So this has no impact. So this will be 0. Again, if we add minus 1 to this, we will be losing 1k. So this will be minus 1. This will be again minus 1, and 3 will have no impact. So this will be 0, and this will be plus 1, and this will be plus 1. Okay. Similarly, we can build that for 3, and after that, after we have built this array, the array will be minus 1 1 1 0, minus 1 0 1 1. So after we build this, we will try to find the maximum Subarray sum from this. The maximum Subarray sum from this will be nothing but 2. Okay, we can take the entire thing, or we can take the last two elements also. We will get our maximum Subarray sum, which is 2. Okay, I hope you get it. And if we choose this array and try to add minus 1 to here, we will be generating 2 ones. Okay, I hope you get it. So that is the solution for this problem. We'll generate this plus 1 minus 1 array for each element from 1 to 50. Okay, and then we will try to find the maximum Subarray sum, and we will add that to the count of k's in the array previously. So let's jump into the solution. So this is the Kadane algorithm. So what Kadane algorithm gives us? Kadane will pass one array to the Kadane algorithm, and it will give us the maximum Subarray sum from that array. I will not explain how Kadane algorithm works. You can check GFG link or any YouTube video for that. Okay, so let's come to the solution. So iterate over each and every element of the subarray. Okay, each and every element of the array. Now we are building this plus 1 minus 1. That's why and here answer is the frequency of k. Okay, answer is the frequency of k. Now we will iterate over 0 to 50, and if j equals to k, we are not building the prefix this plus 1 minus 1 array for k. Okay, so we can ignore that. Otherwise, if numsa equals to k, so we will lose 1 1. That's why we are pushing back minus 1. Now if numsa equals to j, then we will be gaining 1 1. So we will add 1 here. Otherwise, for any other value, we will not be gaining anything or losing anything. So that's why we are pushing 0. Okay. Now for each and every element, we are finding that already the number of ones are here are 3. Okay, already number of ones are 3, and we are converting 2 2's to 1s. So the total answer will be 3 plus 2. That's why our answer will be already count plus the number of ones we will be generating. So 3 plus 2, our answer will be 5. I hope you get my explanation. I'll provide the link of the code in the description box. If you have any doubt in any part of the video, explanation or code, you can always ask in the comment section. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you for watching.